So in the previous lectures, we have seen what is the Sol-Gel method, and we know that Sol-Gel method is one of the fabrication method in bottom top process, right? And we have gone through what is the Sol-Gel method and what is the working principle behind that Sol-Gel method, and we have seen the general mechanism of the Sol-Gel method. So a description of the Sol-Gel process can be the formation of an oxide network through polycondensation reaction of molecular precursor liquid. So this is what we studied in our previous video, right? So this was the working principle, and now why we have to use the Sol-Gel method. So what is the fundamental mechanism to use Sol-Gel method? So the Sol-Gel method has been up to now the most widely used because of the low cost of the required equipment. So this is one of the advantage. This is one of the advantage of Sol-Gel method. That is, Sol-Gel method has been up to now the most widely used because of the low cost of the required equipment. So the mild reaction conditions, and also low cost of the required equipment, the mild reaction condition, and also because usually titanium oxide of the high homogeneity and purity is obtained. So why we need to go for the Sol-Gel method is, so Sol-Gel method is a low cost of the required equipment, right? So the mild reaction conditions, and also because usually titanium oxide of high homogeneity and purity is obtained. Among the advantages of this Sol-Gel method, then what is the fundamental case? Why we need to use the Sol-Gel method? Among the advantages of using the Sol-Gel process in the synthesis is because it can be carried out at room temperature, right? So one of the major advantage is that it can be carried out at room temperature. It allows us to produce a wide range of novel and functional materials. So Sol-Gel method has Sol-Gel method has the advantage that is it can be used in room temperature, and also we can fabricate a range of novel and functional materials with potential applications in different areas, right? So with potential applications in different areas, and finally it is really attractive compared to other methods due to its low cost. So this is one of the fundamental advantage why we need to go for this Sol-Gel process, right? So Sol-Gel process is nothing but why we need to use Sol-Gel process is it is a low cost required equipment. It's a low cost required equipment, and it can also be carried out at room temperature. With this Sol-Gel process, we can fabricate new functional materials with different potential applications in different areas. And finally, it is really attractive. Compared to other methods due to its low cost. This is one of the major advantage of using Sol-Gel method, right? So the Sol-Gel method is considered effective to modify the surface of substrates. So Sol-Gel method is considered effective to modify the surface of substrates, obtaining of a high surface area and stable surfaces. Right? Obtaining of high surface area and stable surface is the most important advantage of this Sol-Gel method, right? So why Sol-Gel method is the fund of the why we need to go for Sol-Gel method is Sol-Gel method is a low cost equipment which can be carried out at room temperature, and also we can fabricate different novel and functional materials with potentials in different areas of application materials can be done, right? And also finally it is really attractive compared to other methods due to its low cost. The Sol-Gel method is considered effective to modify the surface of substrates. Obtaining of a high surface area and stable surface is the most important advantage of Sol-Gel method. So what are the factors affecting Sol-Gel method? So the Sol-Gel reaction consists of a series of simple hydrolysis and condensation reactions. So what are the factors? What the factors affecting Sol-Gel method is series of simple hydrolysis and condensation reaction. So these reactions can be influenced by the reactions. What are the factors affecting Sol-Gel method? Is Sol-Gel reaction consists of series of simple hydrolysis and condensation reactions. So this reaction can be influenced by several factors. That is quantity of acid catalyst, quantity of acid catalyst, amount of quantity of acid catalyst, amount of water used, in incorporation of a network modifier, and varying solvents. So these are the factors. These are the factors which affecting the. These are the factors affecting the Sol-Gel method. So first one is the quantity of acid catalyst. Second one is the amount of water used, and third one is incorporation of network modifier, and fourth one is varying solvent effect. So these are the various factors that affect Sol-Gel method. Now, if we understand the difference between sol and gel. So what is the main difference? What is the main difference between sol and gel? Right? So sol is nothing but it is a disperse phase in a solid material. It is a disperse phase. A sol is a disperse phase. The disperse phase is a sol. The disperse phase is a solid, right? And when a dispersion medium is a liquid. So dispersion medium is liquid. An example, AS2S3, S in water paints, milk of magnesia, etc. So these are the examples of sol. So disperse phase is a solid. The disperse phase in a sol process is a solid. The dispersion medium is a liquid, and arsenic 2S3, S in water, paints, milk of magnesia, etc. are the examples of sol. Right? So if you go to gel, so disperse phase is a liquid. Here it is a solid. Disperse phase is a solid. Here it is a liquid. Right? So dispersion medium. Here medium is liquid. Here the medium is solid. Examples: cheese, butter, jellies, etc. That is what we see gels, gel-like materials. Right? So it's called the gel-like materials. So we have cheese, butter, jellies. Examples are the examples of gel phase. Right? So the differences between sol and gel is, what are the main differences? Disperse phase is a solid in sol method. Okay? Dispersion medium is a liquid, whereas in gel, disperse phase is a solid and dispersion medium is a disperse phase is a liquid, whereas dispersion medium is a solid. Just like vice versa. Here disperse phase is solid. Here dispersion medium is solid. Here dispersion medium is liquid. Here disperse phase is a liquid. So the better examples of gel are the cheese what we use, the cheese, butter, jellies, etc. are some of the examples of sol and gel. Right. So what more examples can be obtained? The examples of sol-gel method. For example, if it is an alcoholic solution, solution, the drying process is done by burning alcohol. After the drying stage, the produced gels are powdered and then calcined. Right? If it is an alcoholic solution, the drying process is done by burning alcohol. Right? If it is an alcoholic solution, the drying process can be done by burning alcohol. After the drying stage, the produced gels are powdered and then calcined. Right? So the sol-gel method is a cost-effective, which can be operated at low-cost regions for fabrication of novel materials. So sol-gel method is a cost-effective method, and due to low reaction temperature, that means it can be operated at room temperature. As is told, it can be operated at room temperature, right? So that's why the sol-gel method is a cost-effective. It is a cost-effective method, and due to the low reaction temperature, there is a good control over the chemical composition of the product. So since sol-gel method can be operated at room temperature, so there will be good control over the chemical composition of the products. So we can control the chemical composition of the products, not the reactants, right? So the sol-gel method is distinguished from other routes of material preparation from solutions or melts such as precipitation and crystallization by two main characteristics. So how can we distinguish? So how can we distinguish the sol-gel method with other routes of material preparation? So that is what the sol-gel method is distinguished from other routes of material preparation from solutions or melts such as precipitation and crystallization by two main important characteristics. Right? So the sol-gel method is distinguished from other routes of material preparation from solution or melts such as precipitation and crystallization by two main characteristics. What are the two main characteristics? Formation of clear colloidal solution due to primary condensation of the dissolved molecular precursors. Right? Formation of the clear colloidal solution due to primary condensation of dissolved molecular precursors. Right? So, since we are talking about the colloidal solutions, we have some colloidal particles. So, these colloidal particles merge during subsequent chelation stage. So, these colloidal particles, so as soon as the formation of clear colloidal solution due to primary condensation of dissolved molecular precursor, these colloidal particles merge during subsequent chelation stage into polymeric chains by chemical bonding between local reactive groups at their surface. That means the colloidal particles merge. The colloidal particles merge during subsequent chelation stage. So at the chelation stage, it merges into a polymeric chain. So it merges into a polymeric chain by chemical bonding between local reactive group at their surface. So these are some of the examples of Sol-Gel method and some of the characteristics which we can differ Sol-Gel method with other routes, where the characteristics form some colloidal solutions and these colloidal particles merge with subsequent chelation stage. These chelation stage are framed into polymeric chains by chemical bonding between local reactive groups at their surface. Right? Now, what are the types of Sol-Gel cell? What are these types of Sol-Gel? There are two generic variations. There are two generic variations of the Sol-Gel technique. There are two general variations of the Sol-Gel technique. One is called the colloidal method. The other is called the polymeric or alkoxide route. Right? There are two types of Sol-Gel method. One is a colloidal method. There are two generic variations of the Sol-Gel technique. There are two generic variations of the Sol-Gel technique. One is called the colloidal method. The other is called the polymeric or alkoxide route. Colloidal method. The other is called the polymeric or alkoxide route. So the differences between the two stem from the types of starting materials precursors that are used. The differences between the two stem particles from the types of starting materials precursors that are used. Right. Sol-Gel method application of Sol-Gel is a method for preparing specialty metal oxide glasses and ceramics. Right. So Sol-Gel method is what we use for the preparation of metal oxide glasses. As we have seen in our previous lectures, so they are specially made metal oxide glasses and ceramics by hydrolyzing a chemical precursor or mixture of precursors that pass sequentially through a solution state and gel state before being dehydrated to a glass or ceramic. Right. So Sol-Gel method application. Sol-Gel is a method for preparing specialty metal oxide glasses and ceramics by hydrolyzing a chemical precursor or mixture of precursors that pass sequentially through a solution state and a gel state before being hydrated to a glass or ceramic. So if you come to the properties of a gel, what are the basic properties of a gel? Right? A gel is a semi-solid. A gel is nothing. A gel is a semi-solid. Gel is a semi-solid. Gel is a semi-solid. Right? That have properties ranging from soft and weak to hard and tough. So these are gel is a semi-solid that have properties ranging from soft and weak to hard and tough. So gels are defined as a substantially dilute cross-linker system. Gels are defined as a substantially dilute cross-linker system which exhibits no flow when in the steady state, although the liquid phase may still diffuse through this system. Right? A gel is a semi-solid that have properties ranging from soft and weak to hard and tough. It means a gel can be a soft material, gel can be a weak, it can be a tough, and it can be hard. So these are defined as substantially dilute cross-linked system which exhibits no flow when in this steady state through the liquid phase may still diffuse through this system. Typical gels are also classified. Typically, gels are also classified as elastic and non-elastic gels. Typically, gels are also classified as elastic and non-elastic gels. There are two types of class. If you come to the classification of gels, gels are also classified as elastic and non-elastic gels by knowing their characteristic behavior. Right. So such gels on heating from dry mass, such gels on heating form a dry mass, and then on contact with liquid they swell up by absorbing it. Then after that they regain their original form called an elastic gel. So we are telling that typically gels are classified as elastic gel and non-elastic gel. We are telling that one is elastic, another is the non-elastic gel. Right. So these elastic and non-elastic gels are classified based on their characteristic behavior. So such gels which are elastic and non-elastic, such gels on heating form a dry mass. They form a what? They form a dry mass, and then on contact with liquid, that mass is nothing but solid, right? When in contact with liquid, they swell up by absorbing it. They swell up by absorbing it. After that, they regain their original form called an elastic gel. Right? So that is what we can distinguish between elastic and non-elastic gels. So the principle of gel charged molecules move through a gel. Principle of gel charged molecules move through a gel when an electric current is passed across it. Right. So principle of gel charged molecules move through a gel when electric current is passed across it. An electric current is applied across the gel. If you apply some current across the gel, so that one end of the gel has a positive charge and other end has a negative charge. Right. So the movement of charged molecules is called migration. Molecules migrate towards the opposite charge. So molecules of a gel migrate towards the opposite charge. So this is we can tell that one of the electrical property of a gel. Right, that is properties of gel charged molecules. Properties of gel charged molecules move through a gel when electric current is passed through it. So that is what. So principle of gel charged molecules move through a gel when electric current is passed through it. In what way the electric current is passed? Electric current is given across the gel, so that one end of the gel has a positive charge and other end has a negative charge. So the movement of charged molecules is called migration. So molecules migrate towards the opposite charges, just like a dipole, right? Just like a dipole. A set of equal and opposite charges separated by some distance, that means they move it, right? So that is what we call it as a dipole, right? So similarly, the principle of charged molecules move through a gel when electric current is passed across it. Now, let us see what is a gel. So what are the types of gel? So we have different types of gel. Gel types are aluminum cross-linked gels, gels cross-linked with an organic cross-linker, biopolymer gels. We have biopolymer gels, monomer gels, polymer self-induced gels, inorganic gels, gels formulated with synthetic organic polymers. Right. So gel types, there are different types of gels. Right. So first one is the aluminum cross-linked gels. So gels cross-linked with organic cross-linker. Right. Other is the biopolymer gels. We have monomer gels, polymer self-induced gels, inorganic gels, gels formulated with synthetic organic polymer. Right. So what is the structure of a gel? If you come to the structure of a gel is a structure very far from equilibrium. For example, the equilibrium state of silica under ambient condition is crystalline quartz, whereas a silica gel is amorphous. Right. So it's amorphous and has a surface area between the range of 100 to 1000 meters square per gram, which contributes a large additional energy to the material. Right. So a gel is a gel. If you come to the structure of a gel is a structure very far from the equilibrium. Very far. For example, the equilibrium state of a silica under ambient condition is crystalline quartz. In ambient condition, in normal condition, the equilibrium state of silica, the normal condition is crystalline quartz. Whereas silica gel is amorphous and has surface area in the range of 100 to 1000 meters square per gram, which contributes a large additional energy to the material. Right. So this is what we come to the gel types and the structure of gel. Right. So if you discuss something behind gel, a gel is a mixture of solid particles suspended in liquid. What is a gel? Gel is a mixture of solid particles suspended in liquid. The solid particles in the gel can absorb water. The solid particles in the gel can absorb water, causing the gel to swell and increase in volume. Right? Increase in volume. So a gel is a mixture of solid particles suspended in liquid. The solid particles in the gel can absorb water, causing the gel to swell and increase in volume. So there are two types of gels, as we know. One is a soft gel, and other is a hard gel. Right? There are two types of gels we know. One is a soft gel and hard gel. So a gel, what is a gel? A gel is a mixture of solid particles. Is suspended in liquid. The solid particles in the gel can absorb water, causing the gel to swell. That means the gel can be swelled and increase its volume. That is, the volume of the gel can be increased when the solid form of gel is immersed in a liquid. Right. So based on that, there are two types of gels. One is a soft gel, and another is hard gel. So the main difference in these two products, has to do with how they are removed. The main difference in the two products has to do with how they are removed. So soft gel nails are known as soak-off gels. Soft gel nails are known as soak-off gels because the nail polish can be removed with acetone. Right. So that is what, when we put some nail polish so to remove that polished surface on the nail, we use some acetone. That's what we tell soft gel nails are known as soak-off gels. Because the nail polish can be removed with acetone. If you apply some acetone on the nail polish that we are applying on the nail, the polish can be removed with acetone. So hard gel is used to add a nail length over soft gel that is used to soleas polish. So that is what, there are two types of gels. One is a soft gel and other gel and a hard gel. The main difference in these two products has to do with how they are removed. Soft gel nails are known as soak-off gels because the nail polish can be removed with acetone. Hard gel is used to add a nail length over soft gel that is used solely as polish. Right? So how the formation of gel takes place? How the gel formation takes place? When gelation occurs, a dilute or more viscous polymer solution is converted into a system of infinite viscosity. Right? When gelation occurs, a dilute or more viscous polymer solution is converted into a system of an infinite viscosity. That is what we call it a gel. A gel may be considered as a high elastic. That means high elastic in the sense the gel is having the property of elasticity, right? Just like a rubber. If we apply some force on that rubber, as it elongates. Similarly, if you apply a gel, may be considered as a highly elastic material, right? Rubber like solid. A gel solution does not demonstrate any flow. A gel solution does not demonstrate any flow when tube containing the solution is tilted. Right? So this is how the formation of gel takes. When gelation occurs, a dilute or more viscous polymer solution is converted into a is converted into a system of infinite viscosity. That is a gel. A gel may be considered as a high elastic or rubber-like material, rubber-like solid, or rubber-like solid. A gelled solution does not demonstrate any flow when a tube containing the solution is tilted. So this is what we expert gel. So nanomaterials, how the nanomaterials are synthesized, nanomaterials by Sol-Gel method. So that how the nanomaterials are synthesized. So by using this Sol-Gel method is, first the precursors plus solvent is taken in this form, and then a solution formation is formed. That is what the colloidal structure. There are different steps. Right. So if you go for the synthesis of nanomaterial by Sol-Gel method, there are different processes. I'll let you know what are the different processes. First one is the hydrolysis process, condensation process, another is aging and drying, and third one is the calcination, and fourth one is the final product. Right. So in the first step of hydrolysis, we take the precursors and solvents, right? So precursors and solvents are formed into solution formation through colloidal structures in solution. These colloidal structures are connected porous called the structure gel. This gel is formed. That is what the second process of condensation is. And during third process, as soon as the connected process, a structure, a gel is formed, it is formed into three types. That is aerogel, xerogel, and cryogel. So this connected porous, the structure gel, when it undergoes supercritical drying, it forms the aerogel. When this connected porous is undergone supercritical drying, we get the aerogel. When it is thermally drying, when it is dried with some temperature, when it is thermally dried, we get the xerogel. That is what we get, xerogel. So when it is supercritical drying, we get the aerogel. When it is thermal drying, we get the xerogel. When it is freezing, when we freeze this particular conductor, this structure, we get cryogel. So these are the different products we get when a precursor solvent, right, on this first step of hydrolysis goes to condensation. After condensation, at the third stage and fourth stage, we get aging and drying. So this aging and drying are done by three processes called supercritical drying, thermal drying, and freezer drying. In supercritical drying, we get aerogels. In thermal drying, we get xerogel, and in the freeze drying, we get cryogels. Right, and this is what the final products obtained, which is the step 5, which is formed by calcination. Right, so these are the step 1, step 2, and step 3, 4, aging and drying, and step 5 for calcination. And step 5 as a calcination. First process is hydrolysis, second is a condensation, and third one is aging and drying. Aging and drying are done by three physical processes. One is a supercritical drying, another is a thermal drying, another freezer drying. When supercritical drying is done, we get aerogels. When it is done by thermal drying, we get xerogel. And when it is done by freezer drying, we get cryogel. Right? And these are the final products. Which are obtained by calcination. By calcination, we get the final product. So this is how the synthesis of nanomaterials takes place using Sol-Gel method. Right? So out of this, the precursors and solvents are the important forms where we get the solution form. These solutions form are obtained in colloidal structures in gels, and these colloidal structures in gels are connected, we get porous form in the form of gels, and then it is again this connected porous is undergone aging and drying by three different processes where we get the final product after calcination. So this is what we speak about. So the Sol-Gel process is more chemical method. That is called wet chemical method for synthesis of various nanostructures, especially metal oxide nanoparticles. Right. So in this method, the molecular precursor, usually metal oxide, is dissolved in water or alcoholic and converted to gel by heating and stirring by hydrolysis or alcoholysis. Since the gel obtained from the hydrolysis or alcoholysis process is wet or damp, it should be dried using appropriate methods depending on the desired properties and application of the gel. For example, if it is an alcoholic solution, the drying process is done by burning alcohol, right? And after the drying stage, the produced gels are powdered and then calcined. So sol gel method is a cost-effective method, and due to low reactive, since it can be operated at low temperature, there is a good control over the chemical composition of the product. Right? As we have seen, the sol gel method can be used in the process of making ceramics as molding material and can be used as an intermediate between thin films of metal oxides in various applications. Right? So the materials obtained from the sol gel method are used in various optical, electronic, energy, surface engineering, biosensors, and pharmaceutical and separation technologies such as chromatography can be used. Okay. So the sol gel process is a more chemical method. A very chemical method in the sense it's a wet chemical method for the synthesis of various nanostructures and various nanoparticles, metal oxide nanoparticles. So in this method, the molecular precursor, as we have seen, this is a molecular precursor, right? Which is molecular precursor. Usually, metal oxide is dissolved in water or alcohol and converted to gel by heating and stirring by using water, by heating and stirring, and by hydrolysis or alcoholysis. Since the gel is obtained from the hydrolysis or alcoholysis process is a wet or a damp, it should be dried using appropriate methods depending upon the desired properties and application of the gel. For example, if it is alcoholic solution, the drying process is done by burning alcohol. After the drying stage, the produced gels are powdered and then calcined. The sol gel method is a cost-effective method, and due to low reaction temperature, there is a good control of the chemical composition of the product. The sol gel method can be used in process of making ceramics as a molding material, right? Molding material and can be used as an intermediate between thin films of metal oxides in various applications. The materials obtained from the sol gel method are used in various optical, electronic, energy, surface engineering, biosensor, pharmaceuticals, and separation technologies. These separation technologies are used in chromatography. Right. So sol gel method is a conventional and industrial method for the synthesis of nanoparticles with different chemical composition. The sol gel method is a conventional and industrial method for the synthesis of nanoparticles with different chemical composition. The basis of the sol gel method is the product of homogeneous sol from the precursors and its conversion into a gel. The solvent in the gel is then removed from the gel structure and the remaining gel is dried. Right? So the properties of the dried gel depend significantly on drying method. In other words, the removing solvent method is selected according to the application in which the gel will be used. Dried gels in various ways are used in industries such as surface coating, building insulation, and production of special clothing. It is worth mentioning that by grinding the gel by special mills, it is possible to achieve nanoparticles. It is worth mentioning that by grinding the gels by special mills, it is possible to achieve nanoparticles. So these are some of the examples that we have seen. There are examples of gel or curd, cheese, butter, etc. emulsion. These are the types of colloidal solution in which both the dispersed phase and the dispersed medium are in the liquid state. Some of the examples of emulsion are milk, cool cream, oil in water. These are all jelly-like stage, right? Etc. So types of gel, there are two types. There are two most common types of gels. The tubes of gel are agarose and polychromate gels. Each of the type of gel is well suited in different types and sizes of the analyte. Polyacrylate gels are usually used for proteins and have high resolving powers for small fragments of DNA around 5 to 500 BP. Right. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.